Hello everyone, I am Meenakshi Chauhan, working as an assistant professor at the IT department, Kite Group of Institution, Ghaziabad. In this lecture, I will be discussing about 8085 memory addressing and interfacing. So let's get started. In this lecture, I will be discussing about some introduction of memory, then how to calculate number of address lines for given memory specification, and then we will see how to draw a memory address map for a given memory chip. Now, what is a memory? Memory is used to store some binary information into a computer. So, memory is integral part of microcomputer system. While executing a program, microprocessor needs to access memory because the set of instruction or the data is stored in memory, and whenever processor executes the set of instructions, then it asks the instruction as well as data from the memory. So processor frequently access main memory to read the instruction as well as data. And these access can only be possible by some interfacing circuit. The processor needs to access main memory with the help of some interfacing circuit. We have two types of primary memory. One is read-writable memory, second is ROM. Read-writable memory, we can read and write the memory, whereas read-only memory allows to read the data only. So in this image, the chip diagram for both the memories has been given. So here you can see the read-write memory chip has read signal, write signal, a chip selection signal, some address lines and some data lines. In read-writable memory, data lines are bidirectional, whereas ROM memory has chip selection pin, read, only one signal, read, it will not have write signal, and some number of address lines and some data lines. And in ROM, unidirectional data lines will be there. So primary memory has two types. One is ROM, second RAM. Read-writable memory is made of registers, and register is made of flip-flops. So a group of flip-flop form a register in read-writable memory. These flip-flops will store bits of information, and flip-flop will be called as memory cell. So read-writable memory is made of group of flip-flops, and the groups of flip-flops will be termed as registers. So here you can see that a read-writable memory is made of registers, and it has some input lines, some output lines. We have input buffer at the input lines, and this input buffer can be enabled by write signal, same as the output buffer can be enabled by read signal. Data will be written to the registers and read from the registers, and we have to uniquely identify these registers. So we have some address lines. Address will be in a form of bits. So we require a decoder so that the address bits can be decoded into one of the location, or we can say one of the register. On the other hand, ROM stores information permanently in form of diodes. So ROM consists of group of diodes, and group of diodes are called registers in case of ROM memory. The number of bits stored in a register will form the word of the memory. So if a register is capable of storing 8 bits, then we will say that word size is 8. If the register is capable of storing 16 bits, then we will say that the word size is 16. In memory chip, all registers are arranged in sequence and identified by a binary number, and that binary number will be termed as memory address. So, memory address is for identifying one of the registers. Every chip has some specification in form of n cross m, where n is the number of registers and m is the word length of each register. The value of m will be in number of bits, showing the word length of memory. Next, how to calculate number of address lines for a given memory. If memory chip is having n number of locations, or we can say n number of registers, then number of address lines will be calculated as ceiling of log n base 2. For example, if we have 4 registers, then the number of lines will be 2. If we have 8 registers on a chip, then the number of address lines will be 3. For 16 register, the number of address line will be 4. 32 registers, number of address lines will be 5. In this way, we can calculate the number of address lines for a given chip. Now, dealing with more than one chip. Suppose we need 8 registers. So according to the 8 registers, we require 3 address lines, A0, A1, A2. If we have 4 register on a chip and 4 register on another chip, then how to configure 8 registers? If we have 8 register, 3 address lines will be there. And for 4 registers, we will have 2 address lines, A0, A1. So now we will see how many lines will be required to select a chip. So we will have 3 minus 2 equals to 1. So A2 pin will be used as chip selection pin. So here, as you can see in this image, 2 address lines are being used to decode one of the 4 registers, whereas A2 is being used for chip selection. We have active low chip selection. When we have A2 equals to 0, the chip M1 will be selected. And when we will have A2 equals to 1, then chip M2 will be selected. So in this way, we can configure a higher number of registers with the help of more number of chips with lesser number of registers. As we have discussed that 2 chips can be dealt with A2 as a chip selection, as we discussed before. So here A2, A0, A1 will be used as a address line for 4 register on a single chip, and A2 will be used as a chip selection pin. What will happen when we have 4 address lines for the same configuration? We have 4 address lines, A3, A2, A1, A0. According to 4 registers, we will require only 2 address lines, A0, A1. So 2 address lines will be used for chip selection, A2, A3. Now we will have 4 combination for A2, A3. So one of the combination can be used for, in this case, both the chips will be selected when A2 will be 0. if A3 will be 0, then chip number M1 will be selected. If A3 is 1, then chip M2 will be selected. So in this way, we can merge more number of address lines to select chip. Here we can have another solution too, but I have discussed only one, because we will have 4 combination of A3 and A2. We have taken this solution for A2 equals to 0. We can take the same as for A3 equals to 0. Now, in this section, we will discuss how to make a memory map. So, memory address map is a pictorial representation of assigned address space. We can show the memory address range with the help of memory map. Now, memory map term is generally used for entire address range of the memory chip in a given system. So, we will see with the help of example. In 8085 microprocessor, there are 16 address lines. So 16 address lines can identify 2 to the power 16 registers. And we will see the minimum address range or the maximum address range for 2 to the power 16 registers. So here we have 16 address lines A0 to A15. Or these 16 lines may have the minimum address all zeros. So minimum address range for this chip will be 0000 in hexadecimal notation. Whereas if all the 16 lines have ones, then this will form the maximum address range for the given chip with 16 address lines. In hexadecimal notation, it will be FFFFH. So all the address will be in range of 0000 address to FFFF address. So in this way, we can represent address range with the help of address map. Now, what will happen if we are using more number of address lines but chip has less number of address lines? Now for this, we have taken one example. Now we will identify or address 256 registers in a chip. So for 256 register, we will require 8 address lines. And if we have 16 address lines, and out of 16 address lines, we are using 8 address lines for identifying registers, then higher 8 address lines will be used for chip selection. And chip selection hardware will be configured with the help of NAND gate and inverters. So these 8 lines will be combined for chip selection with the help of NAND gate and inverters. So here you can see that what will be the address range for this type of chip. Here the range will be, minimum address will be 4 zeros in hexadecimal notation. Maximum address will be 0, 0, F and F. So in this way, we can configure the address map according to the less number of address lines, when the higher order address lines are used for chip selection. In this way, we can make address map for any given specification of memory chip. Now, what will happen if we fix one address lines to a fixed logic? So in previous example, we used 8 lines for register selection and 8 lines for chip selection. What will happen if one or more address lines in chip selection are set to logic high or a fixed logic? Then we can reconfigure this address map. Here, for minimum, 8 lower address lines will have 0, and for maximum address, 8 lower address lines will have 1. Here in hexadecimal, it will be 0 and 0. For maximum address in a hexadecimal notation, it will be F and here F. But what about the chip selection? So here, for example, if we are making A15 at fixed logic, logic high, then it will be 1. All other chip selection lines will be at logic 0. So now here we will have hexadecimal notation for this 8 and this 0. So address range will be 8000 for minimum address range and 80FF for maximum address. So in this way, we can make a memory address map by having a particular chip selection line at fixed logic. So here in this diagram, as you can see that we remove the inverter from A15 line. We make it as at logic 1 or logic high, and this is the fixed logic, and this chip selection hardware will be used to select a chip. So here we have taken example of one address line. We can have more number of address lines at fixed logic, and then we can accordingly make the memory address map. The content of this lecture was taken from book Microprocessor Architecture Programming and Application with 8085, written by Sir Ramesh S. Goenka. Thank you. Happy learning.